the answers written out anywhere because I do not have a teacher's copy. That'd be really a nice thing for them to make, but they didn't. So anyway, we're going to go through homework. So this is, if I'm remembering correctly, we did section, maybe, chapter 2. So this was problems 9 and 12 and 16?
12.
And 12 is the big request there? Is that what I'm hearing?
Yes.
Okay, let's go through 12. And then if you want to go through the other ones, we totally can too. Does that sound fair?
Yes.
Okay. Fantastic. Hold on just a second. I'm just opening up my book here. Number 12. Is this Richard driving home to visit his parents? 125 miles of the trip are on the interstate highway where the speed limit is 65. Does this sound familiar to you?
Yes.
Yeah, I just want to make sure I'm reading the right question here. All right. So let's take a look at it. So 125 miles. I'm just going to kind of write things out here. At 65 miles per hour. Normally, Richard drives the speed limit. That's good. Today, he's running late and decides to take his chances. Ooh, bad plan. By driving 70. Ooh, boo. We're not judging. I am judging. Yeah. Anyway. All right. So we want to know how much time he's going to save. So really, this is one of those sneaky problems where the physics book writers say, we're going to get 2 problems for the price of 1, right? Jerks. Actually, it's 3 because then you have to subtract. So it's like 2 physics problems plus a little subtraction for you know, thrown in there for fun. So we can do this. This first problem, this is going to be your distance. This is going to be your velocity. And you're looking for time. Gentlemen, or friends, are you like, no. Seriously. Pay attention or be quiet. Those are your choices. Thanks. All right. So velocity is distance over time. We need to solve that for time. Using your math algebra skills, you know that time is equal to distance over velocity. Does anybody want me to go through that? I'm super happy to do it if you'd like. Are we okay?
Can you go through it?
Yes, of course. So the 2 steps are, the time is in the denominator. We don't like time in denominator because we want to know the time. So the 2 things that you need to do for a variable if you want to solve for it, number 1 is get it out of the denominator. And number 2 is get it by itself. Out of denominator is first priority. So we want to get it out of the denominator. The only way to do that is to multiply by t on both sides. So we're going to multiply by t on both sides. Let's do it. We're going to multiply by t. Multiply by t. The reason we do that is so that our t's cancel. Now the t is no longer in the denominator. Now we are happier. We're not super happy yet because t is now being multiplied by v, and that's annoying. But we can undo multiplying by v pretty darn easily, can't we? How do you undo multiplying by v? Divide by v. So we're going to divide by v on both sides. The v's are going to cancel, and so you're left with a t on this side and a d over v right here. Does that make it a little more clear?
Yes, ma'am.
Sweet. Thanks for asking. All right, so t is equal to d over v. Boom, we can plug that in. So we got d is 125 miles. These are non-conventional, not SI units. But as long as the units match, it's all good, okay? It's all good. So we got 125 divided by 65 miles in an hour. I'm going to plug that into our calculator. And what do we get for the time when, what's his name? Richard is being a good kid. You guys get, do you have a calculator out? Pull out a calculator if you don't have one. Plug it in just so that, you know, you can humor me. We can find out what it is. Anybody want a calculator? I can use one during my class. But thanks for reminding me. How long on a normal day does it take Richard to get to his parents' house? 1.92? Units are what? Hours. So it takes them almost 2 hours. In the second problem, now all that we're changing is the velocity, right? It's the same distance, different velocity. You could write it out again. You could start with the red thing, d or v is equal to d over t, and then do the algebra. But friends, it's the same problem, right? So once you've done the algebra once, like you don't need to waste your time doing it again. If it makes you happy to, then by all means, please. But for our expedited process, we're just going to say T is equal to same 125 divided by, now it's 70. How long is it going to take? 1.79. So as long as getting pulled over takes less than 0.2 hours, I guess it's okay, right? Maybe financially less than ideal. Yeah. So how much time does he save? We're just going to subtract, right? So 1.92 minus 1.79. How many hours does that save? 0.13. How many minutes is that?
7.8.
We have different numbers coming out there. What'd you say?
I did mine to the.
Oh, to like another decimal? Okay. And so what did you get for this?
For the hours, I got 0.137, so it's
Okay. Yeah. And so how many minutes is that? 8 minutes? 8 or 9 minutes?
Yes.
We'll say about 8 minutes. Okay. So is it worth it? I mean,
Yes.
you know, I'm not going to tell you to speed. I'm not comfortable with that. Follow the rules. Rule follower right here. All right. Does that help with 12? Questions on 9 or 16? Sure thing. All right. Bless you. 16. I need to read the whole thing so I remember what's going on. Ladies and gentlemen, could you be a little quieter? Thank you so much. All right. While running a marathon, a long distance runner uses a stopwatch to time herself over 100 meters. She finds that she runs the distance in 18 seconds. Answer the following questions considering ratios without actually doing the math. Yay. How long will it take her to run a mile? Excuse me. Well, that's a good question. I guess it depends on how many meters are in a mile, doesn't it? That's kind of annoying.
1600.
Are you making that up?
No, 1600.
It's, yeah, it's close, isn't it? It is close. It's like 4 times around a track. Yeah, but it's pretty close. So let's do it. So 16B. So if you work it out, even though it says not to, but if we do, because, you know, we can. So we've got a distance of 100 meters, but we want to convert that to a mile. And so, Rihanna, what did you say you got for the distance, the distance for a mile? Wait, say that one more time. 1,000?
1,609.
Yeah, it's all good. You know, I mean, it depends on how close you want to have it exactly. But anyway, yeah, so that's about the distance. And then what do we know? We know that it takes her 18 seconds to run each 1 meter. Is that fast? Like, that seems fast. So we can do 100 meters per 18 seconds. So you can get a speed in meters per second and then multiply that by the miles. That's how I would do that. Is there a better way to do it? Does that seem reasonable? Yeah. 100 divided by 18 is like 5.5 meters per second, 5.6 meters per second. Yep, so 5.6 meters per second times. Do you think she can maintain that pace? I mean, I'm not a runner. 1609. How long did you guys get? Like 8,900 seconds. Yeah. Oh, did I? Oh, I totally need to divide it. Yes. Thank you. I got myself excited. I totally do. Time is equal to distance over velocity. Thank you. Yeah, that number did not make sense. Like 287 seconds-ish. Is that about what you guys got? What is 287 seconds? 4 minutes.
Wait.
Is that okay? Does that get you where you need to go?
No. I just set up the proportion with how fast you ran the the 100 meters
Yeah,
and then
just, yeah,
Yeah.
perfect. That would probably be more efficient. Sometimes I want to plug it in. Yes. Other questions on the homework? By that, I guess I mean part A or number 9. We're good besides that? Fantastic. All right. I think, let me make sure I'm doing what I want to do. Yeah. I'm going to introduce you to something new today. This weekend I spent some quality time looking at the AP stuff, and friendly reminding myself about all of the things that we get to do and that we have a wonderful opportunity to do this year. And one of the things that we're going to spend a lot of time doing is this thing called ranking tasks. Okay? The reason Liam took physics last year and she just gave me a look like, yes! I've been waiting all summer to do ranking tasks. I'm so excited because they are awesome. So let me tell you, I taught physics for a lot of years without knowing what ranking tasks were. And it was all plug and chug. It was all plug in numbers and get a number, and like we were staring at our calculators all the time, which is fine, but it didn't really mean that anybody understood anything about physics. The thing that I love about this stuff is that you really have to understand what is going on. You have to be able to articulate how things are related. That's why I love them. We're going to start with some easy ones first. So easy, you're going to roll your eyes at me and say, well, why are we wasting our time with this? And then I'll say, just wait. It'll get more fun. Just wait. That's what I say. All right. Welcome to the world of ranking tasks, my friends. You do not have to copy down these ranking tasks. You do not have to copy down all the questions. I would encourage you to have a piece of paper out to just kind of jot down answers. When I'm teaching you these, like when we're doing content and I have ranking tasks in there, it may help to write down the ideas once we've done it. But for this, you do not need to copy this down. It is absolutely not necessary. Shown below are stacks of various blocks. All of the masses are given in the diagram in terms of M, the mass of the smallest block. So M could be 5, it could be 23, it could be 156. We don't know and we don't care. Okay? It could be any number that you can imagine. The question here says to rank the total mass of each stack. Pretty straightforward, but I want you to give it a shot. Go ahead and do this by yourself first, and then I'll let you discuss. Again, even if you can do this stuff in your head, having a piece of scratch paper just to write it down so that when I ask you what the answer is, you can just tell me real quick. Okay? So by yourself, and then I'll let you discuss in just a minute as well.
Bless you. Thank you. Welcome.
Good. Talk to your table mates. Make sure they agree with you. If you're stuck, help each other out.
That's not the question. I think it is.
You think he's taking two? He's the least.
There is that problem in here later. We'll get there. Oh, yeah.
Oh, A.
Just not today.
A near.
All right. So, Harrison, what you got for that answer to this actual question here?
Is A, D, B, E, C, but A and D can be switched to E and C.
Okay, hold on. Say that a little slower so that I can get it all down. A.
A, D, B, E, C, but E and C are interchangeable, and A and D are interchangeable.
Okay, so how could we mark that? That's a good question. Really, they're interchangeable because they're equal?
Yeah.
They have the same? So instead of just like having to say all that stuff, they're interchangeable, blah, blah, blah. We can just write an equal sign. Does that work? And then we can write an equal sign here. And then just to be like absolutely clear and absolutely like there's no question, instead of saying, oh, did they just forget to write an equal sign? Or I don't know. Let's go ahead and just write a greater than sign there between D and B and between B and E. Is that okay?
Yeah.
Ranking is important, but even more important than the ranking is the explanation. So then you're going to tell me not only that the ranks are these, but what's the explanation? Why?
A and D both had 9.
Yeah.
And then E had 6, and C and E each had 4.
Boom. That's your explanation, right? I added them up. There are the masses, and here's the way that I can rank them. There you go. All done. Cool. That was easy. All right. Then we do another one. And then you say, Ms. Cartwright, we did this one already. I already saw this one. I say, well, it's true. The picture is the same. And even the stuff right above it's the same. But the actual task is not the same, right? This time they're asking you to rank the total number of blocks in each stack. Okay? It's not a trick question. It's pretty straightforward. Make sure you can do it. Counting is an important skill. All right, why don't you talk to each other? Have a conversation, go through it. Make sure you agree. Pretty straightforward, I hope.
Why? Because I can't memorize.
All right, Megan, did you guys get it? Yeah, what'd you say?
It was still like
A,
I didn't need to.
A,
B,
okay,
C,
okay. And are they all greater than, or are there some equals, or,
A,
okay?
equal. And then they're greater than the rest of them. And then B,
Is this making sense? Ranking tasks are pretty straightforward, pretty easy, right? No problem. You don't understand? Okay. Gotta be careful, because like I'm gonna take you at your word. So like if you really don't understand, then I want to help you. All right. Last one with blocks, I promise. This is another one of those situations where sometimes we get a little like, eager to grab our calculators. You do not need your calculators for this problem. You do not. Okay. It's okay if you feel like you just like that calculator and you want to snuggle up with it, but I don't think you really need it on this problem. Okay. Not necessary.
What is it now?
All right, Miss Elizabeth, what'd you guys say? Sorry, I didn't mean to catch you off guard. That was just like I was just looking up. Sorry. What'd you guys say?
Is greater than C.
Greater than C, and then what? Equals E? Awesome. All right, we doing okay? So then for the explanation here, you would actually need to go through it, right? Like, I'm finding the average, so I'm adding them, dividing, da-da-da-da. Perfect. All right, fantastic. Let's not do that one. Let's do this one. This gets a little bit more physicsy. Shown are several lines on a graph. Rank the slopes.
Zero. I was like, yeah.
Check with your neighbors, make sure they agree.
Why is it?
All right. Nick, did you guys come up with an answer back there?
Yeah.
Awesome. What'd you get? Okay, my pen was being funny. E is equal to C is greater than B, and then what'd you say? That's okay. I lost track. And then was there an equal here? Or did I mess it up?
C is equal to C is greater than B.
Okay.
That is equal to E
Okay.
is greater than A.
Awesome. Thank you. Sorry. My brain, like my pen was being goofy and then I lost tracking you. All right. How'd I do?
Should
D
is not.
Oh, I'm sorry. Is that what you were saying? He's just like saying, I'm talking to you, but you're not listening. That one? Is that better? Okay. I'm sorry. My hearing's not great some days. I apologize. D is in dog. Come on. All right. D and C are the same. You can prove it. You can count it. You can calculate it, right? Cool. All right. One more, I think. Maybe there are two more. I can't remember. No, I want this one. I want this one. All right. Now we're getting into this physics business. All right. The graphs below show a position versus time graph for 6 boats traveling along a straight, narrow channel. The scales on both axes are the same for all of the graphs. Each graph there's a point marked with a dot. Okay. I did blue out a word, and we'll leave that blued out for now. Rank the velocity of the boat at the point indicated. Rank the velocity of the boat at the point indicated. I'm going to zoom this in a little bit so that these are a little bit easier to see because it's kind of hard, especially way in the back, I think. So these are position versus time graphs. Hopefully when you had your buggies, you were making position versus time graphs, right? I hope. That was my intentions with you. Absolutely feel free to talk to each other. Talk this one out. See if you can figure it out. What are you looking for on a position versus time graph to find the velocity? A slope, yes. Does the dot matter in this question in particular? Is the slope at this point the same as the slope at this point? It is, in this case, okay? And for the next day or two, and then we're going to change things up. We got to take baby steps, right? So the dot really doesn't matter in this case, okay? Really what you're looking for is the slope. So when you've got a velocity versus time, or excuse me, a position versus time graph, and you're looking for velocity, you're looking for the slope. All right, are you ready? Or you need some help?
Got this.
Let's talk about this first one. Let's talk about A. We're looking for the slope, right? So let's look at A. Slope is rise over run. So we're going to go up 1 and over 2. What's the slope of this graph for A? Up 1 over 2. The slope is 1/2. Does that make sense to everybody?
Yeah.
For some people, this is a little tough, and that's okay. We're working on it. We're going to learn. Up 1 over 2. Let's take a look at B. Up 1 over 2. Now, you could look at this as 1 up 2 over 4, and that's okay too, right? It's the same thing. It simplifies down. So how does the velocity in A and the velocity in B compare? Same. It's the same line, just shifted, right? How about C? How about C? What do you do? I don't know. Tell me about the slope. Is it positive or is it negative?
Negative.
It's negative. It's going down, right? So let's count it. Let's just do it. We're going to go down 1, 2. That's not very even. So let's keep going. 3, 4. If we go down 4, we have to go over 3. So the slope is negative 4/3. I'm not going to freak out about that being an improper fraction. I don't care. Negative 4/3. It's fine. How about D? Negative 4/3, right? It's the same line. Again, they just shifted it. E. Is it positive or negative? It's positive. And we're going up 1 and over a bunch, right? 1, 2, 3, 4, 5, 6. And in F, the slope is negative 1/6. So we literally are just going to count them out. We're literally just going to figure it out. We found all the slopes, which means we found the velocities. So now we got the velocities of those boats. And now we just need to rank it. Which one's the biggest? Biggest fraction there? A and B, right? They have the same slope, the highest velocity. Okay, what's next? E, because it's also positive, right? Okay, then what? It's the next biggest. F, and then C and D. We okay? Okay, now I'm not done yet. I'm going to take this word out, or I'm going to bring that word back. The word is magnitude. Rank the magnitude. Do you know what the word magnitude means? You hear it when you talk about earthquakes, right? It was a magnitude 5 earthquake or whatever, right? What does that mean? Kind of like how big it is, right? Yeah. So here's the one thing to write down, maybe in these notes of yours that you're kind of writing. Okay, because this is one of those things that we're going to have to really know. Magnitude can be written for our purposes as absolute value. Distance from 0. Or anything like that. So now, does that change our rankings? Yes. So go ahead and rank it out again. One more time. What does it mean?
The power elements.
It's power. It's so.
Henry, what you got?
Magnitude.
For the magnitudes, yeah. Do you need a minute?
Yeah.
Okay. Check with your table mates. Make sure you got it. Make sure you're there.
Yeah.
Did you get it? Which one has the biggest magnitude? C and D do, don't they? Then what?
A and B.
A and B?
Yeah.
And then what?
Yeah.
E and F? I have a question for you. What does the magnitude represent? The magnitude of the velocity, what does it represent?
Total power.
Not power. Power is something different. How fast they're going, right? Yeah, so I want you to make sure you write that down because that is the like big takeaway from this right here is that magnitude of velocity is really just the speed of the object, okay? Generally, we talk about velocity and we need that positive or negative to tell us if it's going. What does it even mean to be negative? I guess I didn't even ask you that. What does it mean to have a negative velocity? Going backwards, right? You can be going backwards fast, you can be going backwards slow. The magnitude of that velocity is going to tell you the speed. Is that okay? All right. Given the time, I'm going to stop there, but I do need your attention for just